These are the notes for Algebra 2, Section 2.3, pages 89 through 92 in your textbook, and they deal with graphing equations of lines. Now, the main thing that we want to start with when we're graphing equations of lines is dealing with the parent function. All lines are variations of the linear parent function. You need to remember that the linear parent function is y equals x. Now, the graph of the linear parent function we have also seen looks like this. And I want to just very quickly look at some of the attributes of the linear parent function. For starters, we can see that the linear parent function intercepts the y-axis at the origin. Y-intercept of the linear parent function is at 0, 0. Now, the other thing we should be able to see here is that the slope of the y-intercept, the rise over run, is 1 over 1. So the slope of the parent function is 1. M equals 1. These are the basic pieces of information that we need for lines. Now what I want to do is compare the graph of a different line to the graph of the parent function. So here we have our parent function, and we want to graph the line y equals 2x plus 3. And the way I want to go about doing this is by putting together a table of x and y values. So I want to create a table of x and y where I will plug in negative 1, 0, 1, and 2 for x. And we'll see what y value we get. Now, if x is negative 1, I plug in x, I get 2 times negative 1 plus 3. 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. So when x is negative 1, y is 1. If x is 0, then I have 2 times 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. So when x is 0, y is 3. If x is 1, I plug it in. I have 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. And the last one here, I've got 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. So I have these values. Now I want to plot my x and y values, my coordinate points, to get the graph of this line. When x is negative 1, y is 1, so I'm going to put a point at negative 1. When x is 0, y is 3, so I'm going to put a point at 0, 3. When x is 1, y is 5, so I'll put a point at 1, 5. Now when x is 2, y is 7. This does not show up on our graph because my graph is not big enough. But that's not really important. As long as we have at least 2 points, we can graph any line. So what I want to do is I want to draw the line. And I want my line to connect all of the points that I have. Here's my line. And we can look at how these two graphs compare. The red line is the parent function. The pinkish purple line here is my graph of y equals 2x plus 3. And we can see that as far as the y-intercept goes, the y-intercept of my new line is higher than of the parent function. In fact, my parent function y-intercept is at 0. This graph is at 3. You can also see that my new line is steeper than the y-intercept. The rise over run of my new line is rising 2, running 1. Rising 2, running 1 is bigger than rising 1, running 2. Now, we want to graph an equation, and we want to do that as easy as possible. Most of the time, when we get a line, an equation of a line, it will be in slope-intercept form. An equation written in slope-intercept form is y equals mx plus b. This is something you might have seen before, and you will see it again. We have y is the output, as we should remember from our video on on functions. M is the slope of our line, and b is the y-intercept. We call this slope-intercept form because it has the slope and the y-intercept. The advantage of using slope-intercept form is that it's easy to see both the slope and the y-intercept at the same time, and that is very easy to graph. So let's try graphing one of these. I have the equation y equals negative 3 over 2x plus 1. The easiest way to graph this will be to find m, then find b, and then use that information to draw my graph. Now, m is the number in front of x. Here I have negative 3 over 2x, so m is negative 3 over 2. That means that my slope has a rise over run of negative 3 over 2, so it will move downward 3 and over 2. The number at the end is b. So I'm adding 1 to this plus 1. That means that b, my y-intercept, is at 1. Now I can use this information to graph the line. B is my starting point. So I'm going to start at B, and that's at 1. Crosses the y-intercept at 1. From there, my slope tells me that I'm going to move down 3 and over 2. So from my y-intercept, I move down 3 and over 2. And I put another point. This point is over 2, down 3, over 2. If I wanted to repeat this step, I could start from my newest point, move down 3 and over 2 to create a new point. I could also move backwards. Since this is negative 3 over 2, I could move upwards 3 and backwards 2, because I could decide if I want the negative signs to go with 3 or with 2. We can't go with both, but it can go with either one. So I could go backwards 2 and up 3. And we can see that that stayed in line with the others. If I had ended up with a point that was not in this line, then I would know that I did not plot the point correctly. Now I've got a few points. That's enough for me to graph. So that's what I'm going to do. I'm going to graph this line. And there we have it. There's the graph of negative 3 over 2x plus 1.